Hello everyone, welcome to this session. Now I'm going to continuing the using Numpy function. So in this session we are going to discussing about Numpy attributes and commonly used method to create Numpy arrays. So first we are going to discussing Numpy attributes. After creating an array, we often need information about its structure and property. NumPy provides several built-in attributes for this purpose. So these attributes help us to find the shape of the array, number of dimensions, total number of elements, and the data type of the elements. Instead of manually counting rows, columns, or elements, we can use these attributes to obtain the information instantly. Let us see with an example. So np.onesof 3, 3. By using this function, first I am creating a two-dimensional array which consists of 3 rows and 3 columns all filled with 1. Then we can see the attribute. So the first attribute will be random, which means it return number of dimensions of the array. So since it's a two-dimensional array, it will be return a value 2. Then the next attribute will be shape, which means it return the size of the array. So it's a 3 rows and 3 column, right? So the shape will be 3 comma 3. The next attribute will be size. It returns the number of elements in the array, which means total number of elements in the array. So 3 rows, 3 columns. So totally it will be consisting of 9 elements. So it return a value 9. Then the next attribute will be d type, which means data type. It return the data type of the elements in the array. So here we will be creating the array by using the function np.onesof. So all filled with 1, it's an integer. So it will be return a value int 32. Then the last attribute item size, it return the size of element in an array. That is size of individual element in an array. Since it's an integer, it will be carrying 4 bytes. So it will be return a value 4. Now we can understand this by using a example, by using a code. Okay, so if I want to work with NumPy, I have to import the module. So by using this statement, import NumPy as np. First, I am going to create a two-dimensional array by using this function np.onesof 3, 3. So np.onesof 3, 3 itself, it will be creating a two-dimensional array which consists of 3 rows and 3 columns, all filled with 1. It's an integer. So here I am explicitly mentioning the data type d type equal to np.int32 by using this statement. It's a optional one only. If you are not using this also, anyway it will be going to create by using a value 1. It's an integer. So this created array will be stored in the variable arr. So if I am printing this arr, it will be printing this array, two-dimensional array filled with 1. Now we are going to working with attribute. So if I want to access the attribute for the array, we have to pass this attribute by using a dot operator. So arr dot random, which means it will be written number of dimensions of the array. Since it's a two-dimensional, it will be written a value 2. Then arr dot shape of, which means it will be returning the shape of the array. So it's a two-dimensional 3 rows 3 column. So it will be return a value 3 comma 3. Then arr dot size of, which means it will be returning the totally how many number of elements in an array. So 3 rows 3 column, which means totally it will be consisting of 9 elements. So it will be return a value 9. Then arr dot d type, which means it will be returning the data type of the element. Since 1 it's an integer, so in this program we have explicitly mentioned the integer int 32. So it will be return a value int 32. Then arr dot item size, which means it will be return the individual element of an array, that is individual size of the element of an array. So it's a integer, so each element carry 4 bytes, so it will be return a value 4. Then array arr dot n bytes, which means totally how many bytes consumed, it will be returning that. So totally 9 elements, each element carry 4 bytes, so it will be return a value 36 for n bytes. Now I am going to give the comparison of one-dimensional versus two-dimensional versus three-dimensional NumPy array. See the difference. If it is a one-dimensional array, we will be creating by using a single list of element. So single list. So here I am creating with 3 element. So the shape will be 3. So if it is a two-dimensional, I am going to create this by using a list of list. So here I am using two list. This is one list, this is another list. So first list represent first row, second list represent second row. So totally 2 rows. See, each list I am having 3 elements. So 2 comma 3, 2 rows, 3 columns. Then if it is a 3-dimensional, I am going to create array by using a block of list. So this is first block, this is second block. So here we were representing like 2 comma 2 comma 3, which means 2 blocks of 2 rows 2 columns, which means each block will be consisting of 2 rows 3 columns. Next we are going to discuss about Numpy array object, and Numpy array object is a core data structure in Numpy. It is officially called ND array. It stands for n-dimensional array. It stores elements of the same type. It supports fast mathematical operations and large data set. Every Numpy array you create in Python is actually an object of type ND array. So we have to keep a note, in Numpy we never directly working with ND array, we create it using Numpy function, but the object created is always an ND array. We can understand this better by using this example code. So here I am going to work with Numpy, so I am importing the module by using this statement, import Numpy as NP. Now I am going to create a single dimensional array by using np.arrayof function by passing the single list of argument which could be stored in one variable a. Then here I am printing type of a. So type of a, which means I am going to print the type of the array. So if it is a type of the array, it will be printing the answer ND array. Right, so we have to understand one thing. So ND array, it's nothing but it's a data type or class. Then NP array, np.array, which means which it is a function used to create it. Then we are going to discuss about common ways to create Numpy array. So generally we have 4 common ways: using np.arrayof, using np.zerosof, using np.onesof, using np.arrangeof. We can discuss the function one by one. So first we are going to discuss using np.arrayof. So the np.arrayof, it's a commonly used function for creating array. So in this function, by using np.arrayof, so here the argument will be passed a single list of element, so which create a one-dimensional array, a single row of element. The next one is using np.zerosof. So np.zerosof, which means so this argument here, it will be specifying the size or shape of the required array. For example, here the code containing np.zerosof 2 comma 3, which means so here it will be creating a matrix of 2 rows and 3 columns, all filled with value 0, because we are using the function np.zerosof. So this function is useful when we need an empty array structure before storing actual value. So next we are going to see about using np.onesof, which it is similar to np.zerosof. So see this code, np.onesof 2 comma 2. So which means here I am going to create 2 rows and 2 columns. It's a 2-dimensional array filled with 1 by using this np.onesof function. So this function is commonly used in mathematical operations and machine learning algorithm. Then the next commonly used method is np.arrangeof. So by using this np.arrangeof, it will be generating a sequence of value automatically based on the given range. So 1 comma 6. So for this example, np.arrangeof 1 comma 6, which means the first argument represents a starting value, second argument represents the ending value. Therefore output will be 1 to 5, which means it will be using the starting inclusive and stop exclusive rule, which means it will be taking the first value, that is a starting value, but it will be excluding the ending value, that is it will be printing before the end value, right? So this is np.arrangeof. So now I am ending this session. In next session we can discuss the rest of the Numpy things. Thank you for your attention.